Okay, let's do this. Okay, so welcome back. For those of you who are not used, who haven't seen the first episode where we set up everything that we are gonna need in order to start rewriting our things in Rust, I highly recommend you to just go ahead and have a look at the first stream, which I will probably link in the show notes or which you can find in my channel basically. So in this video, what we are going to try to do is figure out how the debugger works and how we can leverage it to figure out what the code is doing. And once we have figured it out, we are basically going to find a very simple function written in C++ in the Mozilla code base and try to rewrite it in Rust. And then we are going to test it, we are going to benchmark it, and do a couple of other fun things. So let's jump in and go for it. So what is a debugger? Basically, what we can do when we run our code and we are trying to figure out what's going on, if something is wrong or not, is use well, the easiest way to go about it would be to use a print statement. Basically, we would print line something like and is and something like that. So what that would do is, well, I'm gonna try to see if I can show it like this. There must be a flag required. I'm gonna, yeah, that's what I thought. So I probably need to no capture, if I recall correctly. This is, nope, no capture maybe? Let's try to see. No, it's not. Anyways, so doesn't matter. I'm going to try to run the test and see what happens. Basically, right here, this is a way for me to print something to the output and figure out what the state of my program is while I am running it. So I'm going to try to figure out what the numbers are, how it behaves, and this kind of things. I'm gonna try real quick to see if it works. If it doesn't, it's okay, I suppose. Oh, it doesn't seem to work the way I expected it to. Oh, that's the very slow Fibonacci, that's why. There you go. All right, so you see here, I am basically printing things and trying to figure out what's going on and what the state is. But as you see, it's a recursive function, so it's pretty hard for me to figure out where exactly I am. And yeah, that's basically the fastest way to debug stuff, I suppose, just smashing some print statements everywhere and trying to figure out what's going on. Now, there is another way to go about it in Rust, which is debug. You basically debug things. I'm gonna run the cargo test again. Oh, there you go. So you get basically the same input, but you know the line number and where you are in the code pace, which sometimes might prove useful, I suppose. Um, since I am very bad and I need very good tooling to reason about the code and what's going on, I'm going to show you a bit about the debugger and not really how to set it up, but how it looks like, okay? So the debugger is a part of the tooling that allows me to play, pause, sometimes even rewind the code and figure out exactly at a point in time what's going on in the code and if something is wrong or not, okay? So basically, I can achieve that by setting what is named a breakpoint. Those are the red dots here, which is the visual cue for me to understand that when the code is running this thing, then it's going to pause the complete execution of the program so that I can have a look around, figure out what's going on. So basically what I'm trying to achieve right now is setting up a breakpoint somewhere and clicking debug. As you can see, there is a function with basically it's being paused, and I can have a look at it. So here, the if statement is probably going to evaluate 2 false, because 10 is not less than 2. So it's probably going to go to the else statement. As you can see here, I have several shortcuts that allow me to step into the function calls or step over if I don't want to dive in. So basically, the Fibonacci of 10 is here, and I can just see that I did not hit the if, and I'm trying to get in and compute the rest of the function. So if I want to step in, I'm gonna step into. I am back into the Fibonacci sequence, but the n now evaluates to 9. So that allows me to figure out if something is happening or not and how it works. Okay, so this is something that is very important because it's going to prove useful. As we are rewriting things, we want to make sure that it behaves well, and we want something that is called observability. Observability is our ability to figure out what is going on in the code, which is very important. Some people are, I suppose, very good and can figure it out on their own. It gets hard very fast. So we might as well have some decent tooling that allows us to set up a breakpoint. If I right click on it, I can edit it with an expression. That means I only want the code to stop when the expression evaluates to true. Let's figure out n equals 7, maybe. Let's see how it goes. Play. And n equals 7. So that allows you to figure out what's going on. You might not want to keep on pressing play until you arrive at the specific part of the loop. So you can add breakpoints, edit them, put some conditions in it. And basically here, for example, I would probably want to place a breakpoint here and figure out if sometimes n is less than 2. Yeah, it sometimes is. So that's going to prove very useful. In order to have that in Rust, you need so a couple of tools that are parts of the basic tooling. So like you need LLDB, which is the debugger for LLVM. You need to install it, and you need to set up a couple of things in your VS Code folder. I don't know if I can show it here somewhere. Probably not. I'll just have a look here. ls, is there a VS Code folder here? No, there's not. I'm gonna go to the debug. Yeah. So if you click on the debug tab, you can see the launch configuration. And that's unfortunately not the right one. I'm gonna show you that afterwards, I suppose. So there are several configurations which allow you to run and set breakpoints and do stuff. Okay, so this is definitely something that's going to be useful. This was the Rustlang side. As you can see, if I call debug, I have okay. Sometimes it can be very, very, very deep. That would be a disassembled version. And yeah, you get a lot of information. Something that's very interesting that just occurred here, and I wanted to show you later, is that if you click the debug and a panic occurs, which is an exception, there is a breakpoint that has been set here down on the left-hand side, which is break on panic. So I am now having a disassembled version, so I can figure out exactly what is going on in the computer. This is, don't be scared of that. I don't understand it either. It sometimes might prove useful though. So this assertion failed. So it's given me a view of what is happening, where I am. And as you can see here, there is a local variables which allow you to understand exactly what the state is. So the expected result is this huge number, and the actual result is 55, which is actually correct because n does not evaluate to 40, and it's supposed to be 40. So that's something very useful once you have a test suite, which is a set of several tests. It might prove very useful to see that The test is not passing, and this is exactly where and why it did not pass. So I would actually not even try to dive deeper if all I was able to do was add print statements everywhere and try to work my way from that, because that's really hard to do. Sometimes you don't have a choice. Here we have a choice because we have total control over the test we are writing and this kind of things, okay? How do we do that in C++? Well, in C++, it's a bit different. As you can see, I'm using G++, which is the GCC compiler. So it's the C++ version of the GCC compiler, which means I actually need to use GDB, which is the GNU debugger. So that's like LLDB for GCC, basically. So there's a couple of configurations here. I have no idea what it all means. What I do know is that the way I have set it up is by adding the correct program, which would be the tester. The working directory, you can have it, you can set a breakpoint as soon as the program starts. This is not what I wanted to do. Do I need an external console or not? If not, the output is gonna be somewhere here or in the debug console, okay? And there are a couple of setup commands, enable 3D printing and this kind of stuff. I'm not really sure I need it. I just left it as is. It might be useful, so here it is. Feel free to copy paste it. I'm probably gonna push it to GitHub anyways. So what I can do now that I have set this up is go to my test file, set a breakpoint, and press F5 to launch the debugger, okay? So here's my expected result is I can hover it, I can figure out what the actual values are, okay? And yeah, there you go. Actual result has been optimized out. What does it mean? It means that sometimes in order to for the code to be really fast, we want to have something that is called an optimization level. That means we are telling the compiler we actually care about the performance and not the observability. For example, the programs that you install in your computer don't have all the variable names and values directly accessible, because that would mean that your binary, so the program, would be bigger. It would be bigger because that would contain the line numbers and everything that is required for us to debug it, okay? So here we are having a problem because when we are benchmarking it, when we're benchmarking our code, we have chosen an optimization level, which is this O flag here, which is level 3, which is, I think it's a huge level. There are like several compiler passes, but this is something I don't have enough knowledge to let you, to tell you about the interesting of that. What I do know is that it has an impact on the performance and observability, of course. That means, let's try that. I don't know if it works or not. I haven't tried it before the video, but right now the actual result is still optimized out. So there might be something else like a debug flag or something I want to be looking for. It might actually occur that we have to add this G++ debug flag. We'll have a look at it if we have enough time at the end of the video. Okay, so that would be the optimization level, how to set a breakpoint, how to figure out what's going on. There's a last thing I might want to try to do here. Let's run that. I'm going to try to get into the Rust Fibonacci. You see, that's the Rust Fibonacci. I suppose it's actually pretty hard. No, it's not even hard. It can actually figure out what's going on in the Rust code and give us the background that we are looking for, which is great. So as you can see on the right-hand side, I have still the same output, but I can dive into the code, set breakpoints, and understand exactly what is going on into the test. I'm going to try that on the C++ side and hope for the best. So that would be the expected result, which hasn't been compiled out. That's good. Let's try to get into the CPP Fibonacci. Okay, so I've been able to go until there, and it kind of bugged afterwards. So I suppose it has to do with either optimization level. Let's try that. I'm gonna get back to the bencher. Where am I? CD bencher. Okay. And I'm gonna make clean to make sure that everything is being built again. And I'm gonna try to put some breakpoints over here. See what happens? Okay, so I need to make build. Am I supposed to just make stuff? Oh yeah, make, okay. And then I'm gonna try, there is no optimization level anymore. Can I do that? No, I'm gonna make test. Make sure the test is compiled. Okay, it is. So the make file is a bit broken, as you can see, but what I'm gonna do, oh, you see, it's not optimized out anymore. Oh, that was the last version. So the last content of the memory. But right here, I am able to get in, and I'm even able to see the exact values. So it has to do with the O flag that I've been passing. And the other thing is I've made a mistake. I actually changed the makefile, but I did not recompile everything. So that's why we couldn't see and dive in on the last pass. Okay, so now that we have seen the debugger, it's actually time to struggle because we are gonna work our way through a function, which is actually a pretty small function, and we are going to try to figure out together what is going on in the function, and we are going to try to write tests to make sure that we understood the behavior and that it's fixed. And then if we have enough time, we are going to try to write the Rust-lang version of it, okay? So if you have seen the last let me switch. Okay, if you have seen the last video, my ultimate goal is to rewrite part of these miscellaneous functions. Okay, those are part of the C++ network Mozilla codebase, and I'm going to try to figure out how it works. And once I understand that, I'm going to try to rewrite it. I'm not sure it's useful. It's just for entertainment and learning purposes. All right. So as you can see, there are lots of functions. Some functions call each other. Maybe I can show you that in my code editor because it might be easier for you to see that. Let's have a look. Is it working? No, I don't think it is. Okay, so I'm not going to be able to show you that in my IDE, which is a bit sad. Oh, here it is. Here it is. It works. So this is the same code as I've just shown you in the code base, but it's running in my computer, on my computer, and there's some linting which might prove useful. So how am I going to go about that? How do you rewrite part of the code base in Rust? Well, there are lots of functions calling each other, so it's kind of hard to just start by, I don't know, rewriting like a huge function calling everything. I'm going to start with very simple functions which are not calling other functions, and I'm just going to work my way back up until I am done with those functions. So basically what I can see here is that there's a toLower function which doesn't look too hard. It's a bit convoluted for me because I don't read C++ too well, but it's just one line with an if, and it's taking a character as a reference. So I suppose, yeah, it's a void function, so it does not return anything. It just transforms a part, the given character to lowercase if it can, and it does not make any change if it can't, okay? So that might actually be pretty easy to start with. And as you can see, the toLower function is being called by two other functions. The first one being net toLowerCase, taking a stir and a length. So that means that you might want to pass it a string and ask it to just put all the characters to lowercase until a certain length. I mean, for example, you would say net toLowerCase This is totally false, by the way, but that's just for debugging information purposes, I suppose. Now, two lowercase, that would be a char array. That would be hello world. And the length would be 4, I suppose. And then that would allow you to just have maybe only the 4 first characters lowered. Okay? Or maybe I should have written it in uppercase, like hello world would output something like, I have probably done enough by one error, but anyways, that would output something like, there you go. So hopefully we'll figure it out. Once we have a test harness, we'll figure out how it works. And there's this one, which actually just takes a string and makes it all lowercase, okay? So I'm gonna copy and paste this code to the RIIR project, which we have actually prepared and set up. So let's go to the RIIR project. I should have probably spelled it another way anyways. That would be the toLower method, okay? And I just pasted it. I need to declare it in the H file too, I suppose. That would be a void toLower, which takes a character by reference. Okay, so we are now actually able to write a test using that. So that's basically what I'm gonna do throughout the whole episode. I am gonna go ahead, try to understand how things behave, and this is the way I go about it. I don't understand what the function does. I don't understand how it works. I'm basically gonna write a toLower test, which would be a toLower test, and hello world. And I just understood that, no, that's supposed to take a character, valid uppercase character. So I'm going to start by just calling the function with a character reference, C equals, I have no idea how to do that in C++, let's figure it out. Character is supposed to have just single colons, and let's say that character C is an uppercase C. Does this even compile? I'm not sure. So this is the phase where you see that I am totally bad and I have no idea how C++ works, blah, 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 non-const, L value, whatever. So let's try to, oh, I'm gonna just pass a reference. Okay, so this is the point where you see that I am not good in C++ at all. And actually I don't need to, because I had the right tools that allow me to figure out if what I am doing is correct or not, okay? So what I'm gonna do is I'm gonna have a character which I call C, which is an uppercase C, and I'm gonna char expected result. So this is the exact same as what we've seen within the last video. This is the setup phase where we set up our environment and control it and make sure that it does what we think it does. So the expected result would be the lowercase c, okay? And what we are gonna do is call toLower, which takes a character by reference, and it returns void. It's very interesting to see that. It returns void. That means there is no result that you can get from invoking toLower. What is actually happening is the character that has been passed just changed, okay? And there's a last thing. So yeah, this phase would actually be the run phase, which we have seen in the last video. That's the run phase. And now we need an assert phase. Now, what is the assertion? The assertion is that the expected result, oh, which we have on the right-hand side, so I don't need to change it. We are trying to make sure that C is now lowercase. I have no idea whether that works or not, okay? I know there's a test.skip or something like this. I have no idea what it is anymore. So let's just leave it that way. I am in the bencher. I'm gonna make test Oh, there you go. So we have a warning right now. So we have been able to invoke, we haven't invoked anything yet. The compiler is not happy with what we just did. It said that there's a extern static inline, extern static, and then there's a static inline void to lower, and it has not been declared as static. So the problem is here I said this is a static function, and here I said that's not a static function, that's just a function. So I suppose let's try to see if it works. Oh, I got really lucky. Okay, so I got really lucky because I have no idea how it works, but yeah, let's just say that. So it's declared static, it's never defined what's going on. So it keeps on complaining. There are two ways I can try to handle it. The first one would be to actually invoke the function the right way, because here I am declaring. Let's try that, because what actually matters to me is to get the internals to work. I want to make sure the function behaves well. Is that a static or not? I don't really mind so far. All right, so I still have an undefined reference because I probably don't invoke the toLower function the right way. Let's try to understand what is going on. cpp.h, that would be a toLower, which come from cpp. How does it work? Okay, okay, so basically that had more to do with the cache than anything, I suppose. So here we have our test, which is toLower test, okay? And we give it a capital C, and we expect a lowercase c, okay? I want to make sure it does not work when we don't put it well. It's very easy to have an actual test that actually tests nothing and to end up with something really wrong, like, yeah, actually the test does not assert anything interesting, so anything could go and we are still saying it's valid. So I want to make sure it passes and I want to make sure it fails. Here I have just made sure that it passes and that it fails. Okay, so part two of that, we want to figure out how the function behaves a little more with a valid lowercase letter. So what happens when we are inputting it a lowercase letter? Well, the name is toLower, so I reasonably expect it to output a lowercase letter and to basically not change it at all. So let's try that. I just have a setup phase with a lowercase c, expect a lowercase c, and that's basically what I get. That's a lot of copy pasting, but here I'm just trying to figure out what's going on in the code base, okay? So here we are, 4 tests, it seems to work well. Let's add another one. Another one that would be actually interesting would be what happens if it's not an upper or a lower case, like an invalid character. By invalid character, I mean something that cannot be lowered. And I think the behavior with a number, for example, or a hashtag or whatever, is to just not change the value. Okay, let's try that. As you can see, it did not change. All right, so we have 3 tests that allow us to maybe try to understand the code a bit more. And we are not sure that it will always behave the way we expect it. But we know that given this input, this is the correct output, okay? So that's pretty good. What we're actually gonna do with that is we are gonna try to write a toLower function in Rust that passes the same test, okay? So what I'm gonna do now is I'm gonna go to the Rustling side. Let's write a little bit of Rust code here, and I'm gonna add tests. which are the same as the C++ test. I'm going to put that on the right-hand side and that on the left. There you go. So on the right-hand side test, on the right-hand side, we have the tests that we have written in C++. And on the left-hand side, we are going to write the same test for the Rustlang version, okay? So we are going to write a test valid uppercase character. So this test is going to need a C, which would be a car. I don't even know if that's possible. So C, and that would be a capital C, okay? And there would be another expected result that would be here. That would be a lowercase c, I suppose. I think there's a car type, is there? Expected a value, blah, blah, blah. Oh, no, that's not. Let's put stir right now. But I know there is a car type in Rust, I think. So we are gonna dive and figure it out on our own. Truth be told, I am a terrible C++ programmer, but it turns out I am also a terrible C++ Rustlang programmer. So that's not a value. Yeah, I'm so terrible. This is the problem you face when you are rewriting stuff around. You kind of mix and match the grammar. I've heard Chris Kreitchow. If you don't know about Chris Kreitchow, you just should check it out. It's amazing. He does Rustlang podcast, and he is doing quite a lot of TypeScript and Rust, and mixing and matching and switching from one to the other is kind of hard first. But anyways, what I want to do is let C equals capital C. I would actually want to make it mutable because the C part is supposed to mutate the character. And I'm going to just Rust to lower and mod C. I'm going to probably going to have to mutate this. I'm going to go Rust to lower, and then I'm going to assert that once lowered, it's a lowercase c. Okay, so once we're done with that, yeah, it's going to be a bit painful. So the first thing we want to do is actually create that function, okay? Rust to lower is a function that takes a mutable reference to a character and actually returns nothing. So that would actually, we would actually write that by either saying that it's a unit or by just saying nothing, okay? So basically, this is the Rust to lower function. And now the compiler is going to start complaining because we did not say that it's a char, I suppose, mutable char, who knows. Now it's complaining that we expected a mutable char. There you go. Okay, so that's good. There are actually two problems. The first one is that the function is never used. It actually is. So we're gonna use, let's just put a use super start to make sure that we actually use all the functions that have been defined above. Okay, there you go. So that would be the Rust to lower, which is here. It's been called. Oh, I'm even going to make it public because I want to use it from the C++ side someday. So that would be Rust to lower. Now the compiler is complaining because there's an unused variable. It's like, you actually told me about C, but you don't use it. So that's a bit stupid, isn't it? It actually is a bit stupid. So we probably want to do something with C, but since the compiler is just telling us about warnings and not hard errors, let's just try to run the test, okay? We run the test and it fails. Of course it fails. It's telling us that it expected lowercase c to be C, but on the left-hand side, I'm just gonna put that back down. Let's put that to the bottom again. It's telling us that, there you go. It's telling us that on the left-hand side of the assertion, which is C, it found a capital C, and on the right-hand side of the assertion, the expected result, there is a lowercase c, which is obviously bad, which is okay because, I mean, we haven't done anything with C yet, okay? So now we have one test that we need to pass. What is the easiest way for us to write something that would have the test actually pass? Well, it's pretty easy. We want to make sure that this character is not lowercase c. And there you go. So actually, oh, that's interesting. It's telling me that I'm not supposed to do that. Let's try to get a mutable reference to that. How does it work? Oh, it does not work at all. It's supposed to be immutable. We are gonna dive into the code base sooner than I thought. So maybe I'm just gonna deref. Okay, that's it. I don't know if you know what happened right now. I am getting a reference. So that's basically an address, a memory address that actually points to the value C. And right here, what I'm trying to do is have it just change the value that it's stored to the lowercase version. So basically, I need to dereference this memory address so I get actually a handle to the actual value and change its value. So I need to dereference the pointer basically. And this is something I can do here, and I could probably not do in C++ as easily, because if I have a pointer to something, I would have actually had to check that the pointer is not null. Like if C is not null pointer or something like this. I have no idea how to write it, but yeah, something like this. If C is not null, then you can do this, else don't do anything or something like that, okay? Because that would actually blow up at runtime. So here, I've actually created a toLower function, and let's try to run the test again. Oh yeah, the test is passing. That's not correct because the next test is probably going to blow up, but we know that the test is passing. So we have successfully written a function that actually does the job for our first test, okay? Now let's try to write the second one. The second one, that would be test.cpp. Let's put it back here and write a second test. So there you go, you get another test, which is fn test valid lowercase. Character, okay. Let's go with the lowercase, let mut c equals c. So here I am actually noticing a flaw in the way I have written the test, because here it's unfortunately gonna work. It's gonna work because the characters I have picked are actually not the best I could have picked. For example, I'm going to assert that C, that lowercase c is supposed to be C. There you go. The problem is this test is going to pass. You see, the test is going to pass, and it's going to pass because as I set up this function, I could have actually picked another letter. And then I'm pretty sure that if I input another letter, since we basically told the function to return C, it's not going to pass anymore. Boom, it did not pass, okay? It did not pass. Lowercase c is supposed to be C, and it's E, okay? So it's very hard at first to find the correct tests, but I suppose the more tests you write, the more confident you get. And here it was actually pretty easy to figure that out. So there's one thing that we need to make sure. We need to make sure that the C++ tests actually pass, because we are not sure of that anymore since we actually changed it. So I'm going to get back into the terminal. I'm going to make clean and make test. Compile everything again. Oh, so this failed, which is actually expected. because this test is not gonna work. I'm just gonna comment it out for a couple of minutes just to make sure that the C++ test pass. There you go. There you go. Valid lowercase character is here. It actually worked. Okay, that's good. That's good because the C++ function works. Unfortunately, the Rust one does not work. Let's have a look at it. What I can do here is put a breakpoint. The function is very easy, but I could have actually put a breakpoint here and figured out what's going on. What is C? It's actually a pointer, so it's going to be hard to debug, but I could actually have a look at the variables and everything that's going on, which is actually pretty interesting. So what I'm going to do here is find a way to put something in lowercase. I have a character, I want to put it in lowercase. It turns out that Rust might have something useful for me. So now we are going to try to dive into the code base or into the documentation and find our way through it, okay? So let's go back to my internet browser and we are going to try to figure it out. Let's go there. Stir Rustlang. So stir Rustlang has a huge documentation. Stir is actually a string. We are not looking for a string, we are looking for a character. Let's go to the character API. Is there something that allows me to go to lowercase? Well, we could scroll through the methods, but we can actually, oh, there is something very interesting here. There is a is lowercase, there is a make ASCII lowercase, a to ASCII lowercase. Those are functions that we definitely want to have a look at. Okay, so let's do this. I just clicked on is lowercase. It returns true if this char is lowercase. Well, that's not exactly what we're looking for. Let's have a look at the next one. The next one would have been make ASCII lowercase. What is make ASCII lowercase? It is something, oh, that's interesting. It is something that takes a value by mutable reference that actually modifies it. It's very, 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 very close to what we actually want. Let's have a look at the documentation. It converts the type to its ASCII lowercase equivalent in place. That's exactly what we want. And non-ASCII letters are unchanged. Wow, that's basically what we want. And to return a new lowercase value without modifying the existing one, use to ASCII lowercase. Let's have a look at to ASCII lowercase. That's probably not the one we want. The signature of the function says that it takes a reference, which is not mutable anymore because we are going to create a new value, and it returns a char. That's a very nice method. That's not the method that we need. Okay, so let's have a look at make ASCII lowercase. Make ASCII lowercase takes a mutable, and we just take it and make it lowercase. By the way, the test that we are seeing right here is very close to the one we have written, which is a very good indication. Let's run it. If you click on the run button on any of the documentation example, you get a link to the Rust Playground. Now, the Rust Playground is awesome. It is a place where you can just hack around, see what happens. Here we have a test that has been written. It's actually worked. We could actually change the values, rerun it. It's not going to work as well, I suppose. Let's wait until it compiles. Hopefully it does. Boom, panic. And you get actually you get the same answers as you just had in the code base because it panicked because we expected a lowercase a and we had a lowercase c. Now that's pretty convenient because that's exactly what we want. So let's just pick that function, the make ASCII lowercase, and put that in our code. I'm going to switch back to the code. Here we are. And I'm going to just use that function. See how it goes. Okay, it didn't say anything. Looks good. I'm going to open a terminal in the library and cargo test, see what happens. Valid uppercase, valid lowercase. Okay, okay. Looks good. It looks really good. Okay, so what we're going to do is we are going to write a third test, which is this one, where we make sure that a non-valid ASCII character or like something that's not a letter is not being lowercase. Okay, so let's write it. It's test invalid character. So the invalid character is going to be a 1, and the expected result is something that is not changed. Okay, lowercase 1 is supposed to be 1. I'm not really sure this comment actually makes sense, but let's just keep it that way. Cargo test, cargo test. All right, the tests pass. That's pretty cool. I think we are almost done. There are a couple of things that we could do to actually improve it. Here, there's a lot of boilerplate because we are always using the same characters, so that's not too good, I suppose. But we could refactor it later. I won't do that in the video right now because it doesn't make as much sense. There is not too much to learn from it, I suppose, yet. Another thing we could do is actually benchmark it to make sure that it behaves as fast as it did on the C++ side. That's pretty interesting. So let's have a look at it. I'm gonna write it here. I'm gonna create a bencher. I'm just gonna copy paste stuff around right now. Now I would like to inline it for performance reason. I'm gonna come back to that probably later once we are done with the test and stuff. If I have a bit more time, I'm just gonna add my bencher here. That's a bit stupid because I am copy pasting stuff around, but I suppose that would be enough for us to understand what's going on. So I'm gonna just benchmark to lower, and I'm gonna call Rust2 lower on emotc. Can I do that? That would be pretty cool. I'm not really sure it works. Oh yeah, it does. That's pretty cool. So I'm gonna add it to my benchmark group, which means when I benchmark, I want to benchmark both functions. And I can just cargo bench my way through it. To lower 0 nanoseconds. Oh, this is bad. I mean, it's so fast. Actually, it's not as fast as it looks. I suppose there is something else going on right here, like maybe it's been optimized out. What I mean by that is the compiler sees that this here is always the same. So maybe it could just invoke the function once and keep it and not even try to benchmark it anymore, okay? So what I'm gonna do here, I'm gonna leave it as is. Maybe I'll just, let's see that. This is a void function. Let char equals, let's, can I do that? Let mut my character equals C. And I want to give it a mutable reference. Does it work? Wow, it works. That's probably not gonna help. Yeah, that's it. So now I might want to tell you a bit more about the black box. The black box, I don't know if it's gonna work, but let's try it. The black box, I'm gonna show you that in the bencher. The black box that you can see here is the benchmark do not optimize function. The do not optimize function actually adds some operation at the assembly level that tells the compiler that anything can happen with the memory. What it means is that the compiler will not be able to make sure that nothing wrong is going to happen while invoking the function. So it cannot keep stuff in cache and assume that nothing is going to change in the memory, for example. And since it cannot do that, it means it will have to always recompute the value. So that's pretty helpful to just do not optimize, because else here, it would just compute the Fibonacci sequence once. And no, yeah, I know Fibonacci of 40 is always the same, so let's just give the output straight away and not compute it anymore. So that might be the reason why we have 0 nanosecond per iteration here. I'm not really sure, but we're just going to give it a try. If not, let's just figure out how to make it actually work later. So I'm just going to have a look again at the documentation, but now it's going to be the documentation of Bencher. Yeah, you see the black box, here it is. So black box, oh, we don't have a proper black box. Let's hope that it's gonna work and that we will actually get results. Let's try to put a black box around something. And to put a black box around something, if I understand the documentation correctly, is that I basically will have to bencher black box this, I suppose. I need to close the function. See how it goes. No, it's exactly as fast. There's probably something wrong I'm doing. Maybe I should generate a new character every time or something like that. The problem, if I do so, is that it's gonna have a couple of issues, because I would actually be benchmarking the random character generation instead of the two lowercase. Another thing that might be the reason is that a two lowercase operation is actually just subtracting an integer from another one, which is a really fast operation. So that's probably something we cannot even benchmark. So that might be another reason why it's 0. A way for us to know that and to try to figure this out would be to actually benchmark the C++ implementation of that. Okay, so let's do that. We are now going to the right-hand side, or maybe I should just make it bigger. There you go. Let's just create a new bencher, which would be the CPP2 lower. Okay, int, that would actually be a char C equals uppercase C. And I'm gonna call to lower on C. How does it go? Are you complaining? Oh, yeah. So the problem with to lower is that it's a void function. So I'm not even sure I can not optimize that. Let's try it another way. Yeah, I'm just not gonna use the benchmark do not optimize. I think that's not gonna work out too well, but let's just give it a try for now. I'll need to research a little bit more on how to benchmark this kind of stuff, and I'll let you know once I'm done with that bencher. I want to make clean, and then I want to make bench. So those would be the rustling bench. And I suppose if I do not benchmark, do not optimize, it's probably not gonna work out too well. I can actually change the to lower method to actually return something. That would probably be something that I can pass to do not optimize. I'm gonna try that just for the hell of it. And once it's done, we're gonna see if there's any change or not. If there's no change, then that will be it. And if there's a change, then we'll figure it out. Another thing, yeah, 3 nanoseconds. 3 nanoseconds is actually something that could be, I suppose, just for subtraction, even though that's pretty low. No, I suppose it's okay. I'm not sure about this one. Anyways, that was writing and benchmarking, writing, testing, and benchmarking on the C++ side and on the Rustling side. The next thing which is probably the last thing we are going to have a look at right now, is how do we add this method to our, how do we make this method invocable? Like, how can we call this new method on the C++ side? So the way I'm going to do that is add another test and 3 other tests. Actually, I'm going to add 2 lower tests. These ones, I'm going to just copy and paste them just for the hell of it. I'm going to add a Rust-lang version of them. That would be 2 lower tests. Let's call that Rust 2 lower tests. Maybe I could have been smarter about the copy pasting here. Anyways, that's okay. Let's create the Rust 2 lower test, and we are gonna call Rust 2 lower. Okay, and the Rust 2 lower. Here it is. Here it is. There you go. It's not implemented. It's not implemented. I need to declare it here. Create a void Rust 2 lower, which takes a char C and returns nothing. I just want to make sure that I'm just not doing it wrong, because what is the exact definition? It takes a reference to a char. Okay, so I'm going back to my declaration and I'm taking a reference to a char. Once I have this, I have declared it for C++ to use. Now I need to declare it on the Rust side to make sure it's going to be invocable. And the way I'm going to do that is by shamelessly copying the Fibonacci that I've used. And I'm going to do that here. We have no mangle to make sure the name remains the same so that we can use it from the C function. We have a name, which is Rust2 where it actually take a mutable reference to a char. I suppose that would be C, which is emute char, and it returns nothing. And that would actually call Rust2 with C. So there are so many things that can actually go wrong right now. I'm not even sure it's going to be working. That would be the Rust2 Oh, that's the same name. Let's give it another name. Internal. That's a terrible name. I'm going to change it later. Internal Rust2. No, that's not what I'm going to do. That's not what I want to do, because if I do that, I need to change all the tests. So what I'm going to do is change the name of this function, internal Rust2. No, that internal makes no sense. Let's just, yeah, let's call that external Rust2. That's terrible. I'll figure something else out later. I'm just declare external Rust2, which is stupid, but yeah. And in the test, I'm gonna call external Rust. Oh, that's not the right. In the Rust2 test, I'm gonna call external Rust2. There's probably something smarter to do with that. Make clean, make build. Let's see how it goes. Make, that's it. I should have called it build, actually. Okay, there you go. So external Rust2, now it's complaining because it's undefined. I don't know what's going on. Let's try to make test. There you go. So we are having a bug right now. Rust2 test valid uppercase character is supposed to return a lowercase c, and it does not. So what is going on here? It seems like the Rust-lang 2 or the mutability here does not behave the way I expected it. So I called something and it probably changed, but I did not receive it. Let's try to see if I can find the cause. This is a chart. No, that's not the correct test. The correct test would be this one. This is a chart, and I'm gonna try to debug that. Yeah, so I have a Oh, as you can see here, char has not changed. So there's probably something wrong with my passing of the reference or not. There you go, emot. That's a mutable reference. That's actually supposed to work, but we have an issue with the copying. So I suppose this is something I will need to figure out. Yeah, I'll need to figure that out, and I'll probably post another video with the correct answer to that. And once I'm done with that, which is actually good, I'm going to be able to just hack my way through everything. I'm going to hack my way through that afterwards. Okay, I think that was it for now. What I'm going to do is post the follow-up video with the actual response and how to go about it. I'll see you around.